Welcome to this tutorial on Istio Security, where we'll explore two fundamental concepts: mutual TLS and authorization policies. Security is a critical aspect of any service mesh implementation, and Istio provides powerful features to secure service-to-service communication within your Kubernetes cluster. Throughout this video, you'll learn how to implement encryption and access control to protect your microservices architecture. Istio's security architecture consists of three main components. First, the Istiod control plane, which acts as the central authority for managing certificates and distributing security policies across the mesh. Second, the Envoy proxies deployed as sidecars alongside each workload, which enforce these security policies and handle TLS connections at runtime. And third, the certificate authority, which is responsible for issuing and automatically rotating X509 certificates that establish workload identity. These components work together to create a comprehensive security framework. Mutual TLS, or mTLS, is a security protocol that ensures both the client and server authenticate each other using digital certificates, while also encrypting all traffic between services. Unlike standard TLS, where only the server is authenticated, mTLS provides two-way authentication. This brings several key benefits: end-to-end encryption of all communication, two-way authentication ensuring both parties are verified, strong workload identity based on cryptographic certificates, and a zero-trust security model where no service is trusted by default. Istio supports three different mTLS modes to accommodate various deployment scenarios. Permissive mode accepts both mTLS encrypted and plaintext traffic, making it the default mode and ideal for gradual migration of existing services. Strict mode only accepts mTLS connections and rejects any plaintext traffic, providing maximum security for production environments. And disable mode turns off mTLS enforcement entirely, which is useful for specific workloads that cannot support encryption or during testing phases. Choosing the right mode depends on your security requirements and migration strategy. To configure mTLS settings in Istio, we use the PeerAuthentication Resource. This Kubernetes custom resource defines how workloads should authenticate with each other. In this example, we're creating a PeerAuthentication policy named Default in the Istio system namespace. The spec section contains the mTLS configuration, where we set the mode to strict. This mesh-wide policy ensures that all services within the mesh must use mutual TLS for communication. PeerAuthentication policies can be applied at different scopes: mesh-wide, namespace level, or even for specific workloads. While mTLS secures the communication channel, authorization policies control which services can access each other. These policies provide fine-grained access control based on workload identity, request attributes, and various conditions. Authorization policies support both allow and deny actions to explicitly permit or block traffic. You can create rules based on service accounts to control access by identity, implement namespace isolation to separate different environments, and define both Layer 4 and Layer 7 rules for network and application-level control. This gives you complete control over the security posture of your service mesh. Authorization policies consist of several key components. The selector field specifies which workloads the policy applies to using label matching. The action field defines what to do with matching requests, either allow, deny, or custom. The rules section is where you define the actual conditions using three types of clauses. The from clause specifies source identity constraints such as service account principals or source namespaces. The to clause defines operation constraints including HTTP methods, URL paths, and ports. And the when clause allows additional custom conditions. Together, these components create powerful and flexible access control rules. Let's look at a practical example of an allow policy. This authorization policy resource named allow frontend is deployed in the backend namespace. The action is set to allow, which means only traffic matching these rules will be permitted. In the rules section, we define a from clause with a source specification. This rule allows traffic originating from any workload in the front-end namespace to access services in the back-end namespace. All other traffic not matching this rule will be denied by default. This demonstrates the principle of explicit allow, where you must specifically grant permissions. Now let's examine a deny policy, which explicitly blocks certain types of traffic. This authorization policy named deny admin is applied to the production namespace. The action is set to deny, meaning any traffic matching these rules will be rejected. The rules section uses a to clause with an operation specification. This policy blocks HTTP GET requests to any path starting with /admin/. Deny policies take precedence over allow policies, making them useful for adding additional security layers. For example, you might allow general access to a service, but deny access to administrative endpoints. To wrap up, let's review some best practices for implementing Istio Security. First, start with permissive mode and migrate gradually to strict mode to avoid breaking existing services. Second, use namespace-level policies for broad rules that apply to multiple services, which simplifies management. Third, apply the deny by default principle with explicit allow rules, ensuring only intended communication is permitted. Fourth, continuously monitor certificate rotation and policy evaluation to detect issues early. And finally, always test policies in staging environments before deploying to production to prevent accidental service disruptions. Following these practices will help you build a secure and reliable service mesh.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.